We acknowledge that we record this show on the land of the Piramonk people and pay our respects to their elders past and present. G'day comrades, g'day Liz, how are we all?
Good.
Okay, so this is our first New Papers episode in a while, and today I've chosen a paper based on just the fact that I think Liz will think the title is self-evidently true. So this paper is called Structural Representation is Analog Representation.
All right, yep.
It's by Corey Maley, and it's just been published in Philosophy and the Mind Sciences as part of their special issue on representation in neuroscience and AI, which was edited by Spivak and Fallon.
Cool.
Yeah, so this is cool that this sort of stuff is being talked about. It's timing well with what we're doing in 101 at the moment, so I thought it was a good opportunity to do a bit more stuff on the nature of representation. Maley's agenda here is to argue for the title of the paper, that analog representations as understood largely from analysis of artificial, computational or representational systems are the same type of thing as structural representations, which are largely understood from natural computational systems, so nervous systems as an example. He then wants to use this identification between analog and structural representations to apply insights from the nature of analog representations to issues from the literature on structural representations.
Okay, can I ask, is he saying all structural representations are analog or all analog are structural? Which is the potentially bigger class?
A tricky question. I think on the face of it, the agenda is that these are identical classes, so that everything that's analog is also structural and everything that's structural is also analog.
Okay, it's not clear to me that, on my understanding of those notions, he needs to say all analog is structural.
What complicates it further is there could be an example of something which is structural but symbolic in the sorts of things that I have in my notes here.
Why would you argue for the harder thing if you didn't have to?
I think the part of the agenda here is to try and marry two literatures which he's seeing as working independently at the moment, so trying to bring in some of the stuff from artificial systems and say, look, the insights we get there apply to nervous system stuff as well, so we should be able to...
Okay, sure.
I think that's why it matters, and that's something we'd be fairly comfortable with as well. I think, Liz, from looking at stuff from artificial neural networks and applying that to at least form hypotheses about how real neural networks work.
Yeah, I don't have an in-principle problem. I'm just worried that they've bitten off more than they need to chew.
Fair enough. Luke, I'm not 100% convinced of the analysis here. We're about to get into definitions, and I think that's where there's some problems.
Sure.
I want to note as well, coming into this, that he does cite O'Brien and Opie, who of course are going to be my main source of things that I'm worried about with Maley's analysis.
Cool.
But the only place that he cites them is their claim that literal isomorphism is too strong a criterion for analog representation in cognitive science.
Okay.
And I think there was more even in that paper that would have been helpful. So let's do some definitions. So what makes something a structural representation? For Maley, quote, the essential feature of structural representation is the presence of some kind of structure-preserving relation between representations and what is represented.
Structure-preserving relations.
Yep.
Okay. So isomorphism is a form of structural representation, but it's the strongest or something.
Yes, that would be right, I think. So before we were interrupted by the animals again, I was trying to say, I'm not completely sure about this, Liz, but I think for those of us who are convinced of the need for a von Eckart-Persian style triadic analysis of representation, we should read this quote from Maley as there being some kind of structure-preserving relationship between representing vehicles and represented objects.
That being the ground of content.
Yeah, so that was the next thing that I was going to say as well, because I think it's pretty weak to just say that such a relationship exists. We want it to be, or at least often people seem to be making the stronger claim of what you just said, that the vehicles represent the objects in virtue of that relationship. To be fair to Maley, I think maybe he just doesn't consider cases where there is a structure-preserving relation, but that doesn't matter to the theory of content determination. Perhaps it's easiest to just take that as implicit.
So read me the quote again.
So this first quote: "The essential feature of structural representation is the presence of some kind of structure-preserving relation between representations and what is represented."
Right, so I guess the thing would be, what distinguishes structural representation from other forms of representation, such as symbolic, is that there is that relationship. So it's a claim about pointing to the group, not defining it.
Yeah.
So symbolic relationships are not structural because there's no structural preserving relation.
Or at least, if there is that relation, it's not what's actually grounding content.
Yeah.
Which is the stronger claim. And that because there are some, even in like who he quotes as examples, who I think are making the stronger claim, not just that the relation exists, but that it's what's grounding content. So this is from Artiga. Quote, "Structural representation, a mechanism in which a structural correspondence between a set of vehicles and a target domain is used to accomplish a certain task. As a first approximation, structural correspondence refers to some kind of structural similarity between a set of entities and a target domain." End quote.
And so is this a notion that comes from neuroscience, you said?
Yes.
Right, yeah, okay. So you see lots of correspondences like that in, say, the visual system.
Yeah, so actually that's a good point to come in with my next question, Liz, which was just thinking about what we've talked about so far in this series. What sort of stuff would seem to meet that definition?
I want to say colour space, but that doesn't really work because it's mapped by making judgments and it's not clear where the actual structure in the head is.
Oh, I was going to say colour space as well. In terms of public representations, then, as opposed to mental ones, the kind of thing Maley is talking about here is a map where each point on the map corresponds to a point in space, and the distance between them on the map is scaled so the distances correspond to the real distances in space. Scaling here being the structure-preserving relation. So that's what Maley's talking about when he's talking about structural representations. What about analog representations, Liz? What are those?
Depends. They can mean continuous, or it can mean they resemble.
Yeah, so resemblance is what I think's helpful here, especially when we're thinking about different kinds of computation and what does the causal work, whether it's the resemblance of the vehicles to the objects or the rule-governed manipulation of symbols. Maley has something different in mind, though in arguing analog and structural representations are the same type of thing, I think he ends up in the same sort of place that we find helpful. But you will be pleased to know that he does not conflate analog and continuous.
Right.
It notes that an analog clock that counts seconds by ticking in discrete steps is still an analog clock. For Maley, what makes a set of representing vehicles analog is that they vary monotonically with what they represent.
Very monotonically.
Yeah. Monotonic here meaning that order is preserved. So a mercury thermometer is the go-to example here. Each height of the liquid is a representing vehicle, and their order preserves the order of temperatures. So that is, as temperatures increase, the height of the liquid goes up.
the state of play. So this is where I'm a bit out of touch. So the state of play is there's this group of people talking about analog representation, and this distinct group of people talking about structural representation. And he's trying to say to them, hey, you're talking about the same thing.
Yes.
Okay.
And specifically that insights from the analog literature.
And once you realise
structural,
once you realise you're talking about the same thing, you can make progress because the different fields have made progress on different problems. So there's going to be a lot of definitions. Hey, you're talking about the same thing stuff going on.
Yeah.
Okay.
So we've got a couple of notions here. Monotonic variation, which he also calls mirroring. That's preservation of order. That's where the mercury thermometer example came in. And we also have this notion of structural similarity.
Which is weaker, where you don't have that monotonic preservation.
Well, these are the two notions that are coming from the different places. Right, so we had the structural similarity that was from Artiga's definition of structural representation. And then we've got this idea of monotonic variation or mirroring, which comes from the analog literature. So this is where Maley's saying that these literatures should be making contact because both of these notions are describable in terms of homomorphisms.
Right. You better tell people what homomorphism
I surely will. A homomorphism is a structure-preserving mapping, and we can get our head around that by thinking about the thermometer again. So we have our set of temperatures. That's our set of represented objects, and the heights of the liquid in the thermometer, and those are our representing vehicles. The order of heights of the liquid preserves the order of temperatures, so increasing height corresponds to an increase in temperature. Now, if every different temperature maps onto a different height of liquid in this monotonic fashion, then you get an isomorphism. So this is a very strong relation preserving mapping where you have every height and every relationship between the height corresponds to a temperature and relation between the temperatures. A homomorphism is sometimes just referred to as a weaker version of an isomorphism, and this is where instead of having a one-to-one relationship of temperatures to heights, you have a many-to-one relationship. So suppose you made a thermometer where the liquid could only settle at a height corresponding to each half of a degree, then you'd have a many-to-one mapping. Say 2.1 degrees and 2.12 degrees would all settle to the height corresponding to 2 degrees. Now, even when we use a real mercury thermometer, that does form an isomorphism between height and temperature. We generally can only make use of the homomorphism because we can't perceive sufficient differences in height. What matters here is that the homomorphism weakens the requirement that a set of representing vehicles and a set of represented objects have the same number of items and relationships. The other reason that Maley prefers homomorphism is that it allows us to bring in a consideration of resolution. So a thermometer that's height can settle on every 10th of a degree has a better resolution than one that can only settle on a height corresponding to every half a degree. So what we're looking at there with resolution is the smallest representable difference. In one instance there, it's a 10th of a degree, in the other, it's a half of a degree. All right, so we've gone round a bit, but that's what we're talking about in terms of analog and structural representations, and the idea being that both are understandable in terms of homomorphisms. So next, Maley says, quote, "Perhaps the most useful feature of analog and structural representations is the fact that they take advantage of particular features shared between representations and what they represent," end quote. In other words, content is grounded in resemblance, and that resemblance matters causally in the computations the representing vehicles enter into. I say that's clearer, possibly only clearer for you and I, Liz.
Yeah. I was going to say we need to keep doing 101.
After the next 2 episodes of 101, hopefully that will be clearer for people that aren't us as well. At this point in the paper, I think, is where Maley's reluctance to talk about resemblance begins to trip him up a bit. It makes him a bit too focused on the importance of magnitude, which I think is a barrier to the generalizability of his argument. He asks us to consider next an odd thought of thermometer, one where 0 degrees corresponds to 12 centimetres, 1 degree to 44 centimetres, and 2 degrees to 5 centimetres. So, Liz, if I made such a thing, what sort of representational system would that be, aside from weird?
Is there a mapping at all? Oh, it's symbolic. Right.
Yeah.
Sorry, I was trying to look for an analog pattern.
Yeah.
No, there is no analog pattern.
Yeah.
Okay, cool.
What Maley points out is that we can also, as well as having this arbitrary relationship between height and temperature, we can define an arbitrary relationship between the temperatures, call that big R, and between the heights, call that little r, such that for each big R, there is a corresponding little r. So we can just make up an arbitrary relationship. But because here you now, if you just invent these relationships, then you do have...
Oh, you do have a correspondence, but it's arbitrary.
Yeah.
Okay, sure.
So you have homomorphism here, but it's not monotonic, which is magnitude preserving.
Not sure it's carving things up in the right way, and I have a hunch that it might end up being too strong. And so exclude some types of... Will it or not? Preserve magnitude. What about when there's no magnitude? What's the magnitude of a colour?
Yeah.
When you're talking about hue as opposed to saturation.
Before we get to that, we'll just take a step back. So we've got this with thermometer. 0 degrees is 12 centimetres, 1 degree is 44 centimetres, 2 degrees is 5 centimetres.
Okay, so that doesn't preserve the order.
Yep. It doesn't preserve the order, but if we make up arbitrary relations, it could still be a homomorphism. All right, so we're agreed that even if we make up arbitrary relationships between vehicles and between objects, so between heights and between temperatures to correspond to each other there, so we have a homomorphism, we don't have an analog or structural representation. What Maley says is, quote, what is required to make this an analog representation is rather obvious. Instead of using some arbitrary relation among the elements of each set, we need to use a natural relation, end quote, whereby natural, quote, simply means a relation that preserves the ordering structure among magnitudes, end quote. Using arbitrary relations, we, quote, do not track the inherent magnitude structure of either domain, end quote, that is temperature and height. So the arbitrary system, quote, fails to constitute an analog or structural representation precisely because it does not preserve the structure of the magnitudes, end quote. So this is sort of how he's getting tied up into importance of magnitude, because he's sort of seeing that as the only non-arbitrary relationship. This is where I think he is being too restrictive in terms of thinking about magnitude as the only non-arbitrary relationship, or what he calls natural relationship.
What things don't have a magnitude? Colours. Do colours have a magnitude? What, to the extent that you can arrange our experiences them in space, they have a magnitude? I mean...
Yeah, so I don't think that this is necessarily wrong, because you can, if you think about colour space, you can define each point in that as a vector. Yeah, and then the vectors, you can call those magnitudes if you want to.
What is it about them that means you can call them a magnitude so that the notion doesn't become vacuous?
Well, because a vector has length.
Right, yeah. Okay, right.
Yeah.
But that's a representation of the colours, not the colours as a thing.
Some work would need to be done there. Maley is going to try and do this work by providing an analysis of photographs. And I think this is a helpful example because we can see how forced it is and how much a lot of this is driven by, I don't say resemblance bias. All right. So he's going to make a lot of magnitudes. Like I said there, it's, I think, because he sees that as the only non-arbitrary relationship between vehicles and between objects. So the application of magnitude to photographs, I think, is quite forced. So he says, quote, light intensity values at points in the photograph preserve the values of corresponding points in the image being represented, end quote. So I can sort of see where he's coming from if we're considering the use of digital photos as indices. If we're using a digital photo as an index of just the particular instance that it took a photo of, this might be okay. But if we think about a different way that we can use a digital photo to represent, like we could have a children's book that uses a photo of a bear to represent the class of animals, bears, rather than just that particular bear climbing that particular tree at that particular time. Now, if we do that, it's not the light intensity at a particular point that's doing any representational work, or at least it's not just that. Because if you got people to match a bunch of photos based on what's depicted in them, then they would sensibly put a faded picture of a bear with a vibrant picture of a bear, even though the light intensities of the vibrant one would be more similar to the light intensities of a vibrant photo of a dog. Look, we want to see where he's going with this, but at this point, I feel like he is forcing the magnitude stuff in rather than just dealing with exploitable resemblances or something like that, which was the natural thing to do with photos. I wanted to say as well that it's not that we have to think that magnitudes are completely the wrong way to go for the mind. So activation space vectors could be considered magnitudes. Like we said before, points in color space can be considered magnitudes, and he's about to do some multi-dimensional stuff. But I think why those things matter, vectors in activation space or vectors in color space or something like that, you can really only see why those matter if you've done work on second order resemblance between sets of vehicles and objects. And it's that resemblance which does the representational work. So to then say it's the magnitude that's doing the work feels pretty forced to me. So I want to keep going with his argument, and we'll go with dimensionality as the next part here. So a thermometer is a one-dimensional representational system. It's just variance by height of liquid that matters there. So then if we come back to his example of a digital image, and we'll do a grayscale photograph here, just to simplify a touch. This he considers to be two-dimensional because it is made up of a two-dimensional grid of points. Lightness or brightness, if we're doing one on the screen, varies by the location specified by those two dimensions. Liz, I think you might be able to guess already where my hesitation is going to come from here. But I think there's some conflation here between how the photograph is made and how it represents. And I think that this is probably the underlying concern I have with Maley's analysis.
So he's focusing on how it's created, as in the causal relation.
Yeah. So that's okay if we're only considering the use of photos as indices, as an index of the particular moment the image was taken. But this is not always, and I suspect really not even often, the representational relation we exploit when we're using photographs. I'm going to read a quote for you, and I'm going to want you to tell me, based on this quote, what you think Maley is saying is represented by a photograph.
Mm-hmm.
All right. So this is the quote. We have a two-dimensional grid of points where each point represents the luminosity of the image being represented. Importantly and obviously, once made explicit, the structure of the points of the representatum, the image being represented, is preserved by the grid of points in the representation. End quote. What do you think? What's being represented by the photograph there?
Is he talking about a photograph and then a digital representation of the photograph, or a digital photograph and the object the photograph represents? I'm really confused.
Yeah. So I'm just going to pick out two phrases here, which I think are what's confusing you, and certainly what that confused me. So here we go. Each point represents the luminosity of the image being represented.
Yeah.
This read to me like he's saying a photo represents an image.
Yeah.
But I'm not at all clear on what this thing, the image, is meant to be, aside from the photo itself.
Yeah.
So,
okay. So
maybe this is specified elsewhere in his work and just not in this paper, but I found this quite confusing. So where he goes from this is he talks about two different ways that you can produce a photograph using magnitude at different points to represent this thing. The image one is by having brightness at different points vary. The other is to make something where you just use the height of something at each point. So you end up with a sort of 3D graph where X and Z are the coordinates of the pixels and Y, you have the height of a graph indicating brightness. As I said before, I didn't think that was super helpful because I think it conflates how the photo was made with what it represents. And like I said, I think generally photos can be indexes. Like you can use a photo to represent a particular thing, So I don't know, if you were like trying to work out who stole something from a shop, you would use an image from a security camera of that particular instance to represent that.
The crime.
Yeah. And there you would be representing that particular thing so caused. But I think that's an unusual use of photographs. I think much more common is things like, even like if you'd have an image of the Eiffel Tower or something like that, people don't use that just to represent the Eiffel Tower at that particular time from that particular angle. They use it to represent the object. Or better, I think, is the example of using a particular photo in a children's book to represent the class of things. We've gone round and round a little bit there, but the way I'd like to sort of express my core worry about this example is that by focusing on how the vehicles are constructed, I think Maley isn't necessarily picking out the content determining relationship between the vehicles and objects. In particular, picking out the content determining relationships which are exploited by a consuming system, so which are used by an interpreter.
Yes, and that's a very easy mistake to make.
I guess that the main upshot of that is, if we're going to get our heads around the positive work from Maley here, I think it's better to use the thermometer or a scale model example rather than the photograph.
Yeah, photographs are really tricky.
Yeah.
because you're right, because they represent a specific, they inherently represent a specific event, but at the same time, we often use them to represent something more general than the specific event that causes them.
Yes.
The features of the resemblance that we're using become quite difficult to say in words.
And it's really driven by what you said there. Just putting that a different way would be that there are two content grounding relationships for every photograph, which are used at different times and for different purposes. There's the indexical one, so
Eiffel Tower as we saw it during the beautiful sunset on the trip.
Yeah, and the resemblance.
And the Eiffel Tower, per se.
Yeah.
Yeah.
So at this point was when I wanted to sort of bring in another sort of underlying worry that I had with Maley's reading, which is I think he has a bit of an attitude of just don't say resemblance and don't say second order resemblance.
Why would he be aware of that as a thing to say?
Well, because of some of the quotes I'm about to give, but also because he does quote that O'Brien and Opie paper. And this comes up here, and I think causes a bit of a headache here, because at this point he wants to remind us of some definitions of structural representation and to see how those apply to the analog case. He's going to give us a quote from Sawyer and another one from Schier. This first one is from Sawyer. Quote, structural representation, the pattern of relations among the constituents of the represented phenomena is mirrored by the pattern of relations among the constituents of the representation itself, end quote. And from Schier, quote, structural representation, a collection of representations in which a relation between representational vehicles represents a relation between the entities they represent, end quote. Now, what I'm not clear on is why you would say those two definitions are one class of things, unless you're going to say that they both involve second-order resemblance.
So explain to me what's different about them.
So the Sawyer's talking about the relations among the constituents of the thing represented, and Shay's talking about relations between different entities. So Sawyer's is about the parts,
yeah,
and Shay's is about relations between different wholes. Anyway, I think that Maley's saying that wanting to group the definition from Sawyer and the definition from Schier together because they both involve homomorphisms of some form, with the stronger version of that claim and more interesting version of the claim being that they both represent in virtue of that homomorphism, be it first or second order. The next question is, does any of these ideas about representation, all of the examples that we've given so far have been about public representations, does any of this apply to mental representation or nervous system representation, which is, of course, what we're going to be more interested in terms of, ultimately, consciousness? Maley gives some examples here, none of which I found to be especially helpful because he didn't do the second order stuff. And again, I think conflates how a representing vehicle is constructed with how it represents. So, Liz, do you want to guess some of the examples that he gives?
It'll be in the visual system. There's tons of resemblances.
Yeah. So, retinotopic organisation, V1, is one that gives place cells in the hippocampus that we talked about earlier. Penfield homunculus.
Oh, that's the body.
The body one, yeah. So, get our heads around what he's saying here. Retinotopic organisation of the primary visual cortex. What's that?
If you torture a monkey and so you hold it in place, you measure what the individual cells in V1 respond to, you find that there's a peak response for a particular place in the visual field. Measure activity of individual neurons in V1. They fire like crazy to a particular point in the visual field, and then as you move, say, left to right in the visual field, you also move left to right in the visual cortex.
The quote I've got here is adjacent neurons, that's in V1, so primary visual cortex, respond to adjacent locations in the visual field. And
see, so I end up talking about the experiment itself.
And Maley talks a bit more about things as well, obviously a bit more than the quote that I gave. So Maley says this is a standard example of a structural representation, and it's analog because, quote, we have two spatial dimensions, the independent variables along which receptive field locations vary. At each location in V1, neural activity, the representation, varies with light intensity at the corresponding location in the visual field, the representatum, end quote. That should sound familiar because that's pretty much how he described photos.
Right.
So it's a bit like V1 is a digital photo of the image at the retina. Yeah.
I think they sort of actually did that in the experiment.
Yeah. It's easy to make fun of things as being a bit, V1 is a screen the person in the head looks at. But there is a serious problem around here, which is why would we think that the mere spatial location of a particular neuron is what's exploitable by the consuming system? These examples, like retinotopic organization of V1, don't seem to be getting at what's important about how representation is working. They're saying something about how the vehicles are constructed, but not how content is grounded or the vehicles are interpreted. So then our question is, why is Maley interested in these examples rather than stuff on activation space? There's a couple of things going on here, and this is me trying to make sense of it. One is the don't say resemblance bias that I mentioned before, and to understand activation space, you really need to look at content grounding through resemblance. The other thing that's going on here is that he's trying to support the claim that, quote, the preserved structures between vehicles and objects just are magnitude structures along one or more dimensions of variation, end quote. And that, quote, a supposed structural representation that failed to preserve magnitude relations would either not be a genuine representation at all, perhaps like the arbitrary relation preserved by the mapping in the weird thermometer example that we talked about, or if it is a representation, it would be characterized as some other type of representation, perhaps a symbolic one, end quote. Why does this all matter? The stuff about magnitude, why does that matter? I think what Maley is getting at here is it's preserving magnitude relationships is what makes a representation exploitable, so usable as a representation.
Right, yeah.
Yeah. So here we're finally getting around to interpretation, but I don't think it's very well justified here because Maley doesn't explicitly talk enough about things like interpretation or exploitability or exploitation, etc.
And I think that's what I was trying to get about V1. Oh, wow. That suggests that maybe that resemblance matters, but it doesn't yet tell you how it's usable.
Well, yeah.
And why it matters.
Yeah. So this is what he says about magnitude being exploitable. Quote, relation-sensitive mechanisms can exploit structural correspondences precisely because the preserved magnitude structures allow valid inferences. Suppose representations A1 and A2 represent B1 and B2 respectively. If some mechanism can determine or detect or read off that A1 stands in relation R to A2 and R preserves some magnitude relation S between B1 and B2, then the mechanism can infer that B1 and B2 stand in relation S. Exploitability here depends on the preservation of magnitude structures. End quote. But if instead of R preserving a magnitude relation S, it preserves a similarity relationship S prime, then the inference that B1 and B2 are in relation S prime is fine for a similarity sensitive device, like a standard feed-forward classification neural network. Essentially here, I'm not sure what Maley thinks is special about magnitudes. And like I said before, I'm not saying that he's definitely wrong. I mean, vectors can be conceptualized as magnitudes. That's fine. But a lot of work here is being done by the running together of magnitudes and their natural relations, like in the earlier quote. And yeah, using arbitrary relations, like with the weird thermometer, it gives you a different kind of representation. It gives you symbols. But why are magnitudes the only thing that's allowed to be natural here? So despite the fact that we thought that the title of the paper was self-evidently true, I'm not sure how you feel, Liz, here. I'm not convinced of some of the details of the work. So I think we're okay, though, with the core claim that in some literatures you get things called analog representing vehicles, in others you get structural representing vehicles, that they are what they are because there's some sort of homomorphism between the vehicles and the represented objects.
Mm-hmm.
That we're on board with. So after that, there's a section on why it doesn't matter that homomorphisms aren't sufficient for representation, which we can largely skip over there. He spends a lot of words saying he doesn't need a general account of representation to talk about how analog and structural representations are different from other kinds of representation, and then that any homomorphism is only a candidate for analog representation, and we need some independent criteria for establishing that the homomorphism actually is a representation. I think it would have been much quicker here if he had just used von Eckart's Persian analysis and said that whether something is interpreted is the difference between something being a candidate for analog representation, for an analog representing vehicle, and it's actually being one. That would give ground to claims like, quote, liquid thermometers represent temperature and not something else because of how we design and use them, end quote. Anyway, otherwise I think that's all fairly standard. I just think it would have been clearer to do it in von Eckart's language. Then we want to think about what's the value in claiming that analog representations are the same thing as structural representations. So he applies this to a couple of issues in the literature. He considers a proposed taxonomy of structural representations from Fatchen and colleagues, and concludes that some are and some aren't structural representations by his account. He also says that those talking of structural representations should follow the analog folks in distinguishing between the representing vehicles and the computations they enter into, which is good, if that indeed is something that's not being done enough in the structural representation literature. That's important. But here he doesn't say anything about the different kinds of computation and why different kinds of representing vehicles might do causal work in different ways in those computations. And at least one of the examples he gives here is of digital computations using an analog vehicle as an input, which isn't super surprising because he's using liquid thermometers with a digital scale written on them as a sort of classic mixed kind of representation as his guiding example. But that's fine. Not every paper needs to touch on every issue. We're then at my notes for the last section of the paper, which is an argument that analog structural representations, or ASRs as he's now calling them, can be distinguished from indicator representations. This matters because some people have apparently made an argument that indicators are the limit case of analog representations. So here we want to refer back to Maley's notion of resolution. Some indicators are analog representations with resolution so low they can only indicate if something with a magnitude above a particular threshold is present or not. Maley responds to this by distinguishing between indicators that if you improve the resolution, in his sense, that you end up with something that's analog, and those that don't have resolution to improve. I didn't want to go through this in too much detail because I've already been talking for a long time, and because I'm not convinced that consideration of indicators really matters for cognitive science. Though, interestingly, there, Maley does think otherwise, because he says, quote, "The distinction matters for cognitive science. When investigating whether a neural system employs structural representations, we can ask whether the system preserves magnitude structure or merely detects binary conditions. A neural population that responds gradually to increasing stimulus intensity is plausibly an analog structural representation, even if in a particular experiment we only measure whether it exceeds a threshold. A neuron that simply fires or not in response to the presence or absence of a specific stimulus might not be, unless there is evidence that firing rate, temporal pattern, or population activity preserves underlying magnitude structure." End quote. So we could talk about the plausibility of such detector neurons, but why I wasn't interested in this for CogSci was slightly different. I think it's another case of what I was worried about before, where there's too much focus on how the vehicle is constructed to determine its content, rather than looking at the content-ground relationship. And I'm not sure that that's really relevant to the mind sciences. So I'd just be repeating myself, and I thought I would leave it there.
Yeah, it just all feels a bit wonky.
Yeah.
But that's not a criticism. It just means we're thinking about it differently.
Yeah, and clearly we do think about it quite differently to Maley. So some of the tools that we'd use to structure this around von Eckart's triadic analysis, the different kinds of content grounding relations that we would use to frame the discussion, Maley doesn't use, and so for us it is a bit of a confusing paper. But I think where that matters is without them, I think he ends up focusing on the magnitude stuff too much, and that was where I started to not be on board with the analysis for the reasons that we talked about.
So how does he use it?
I skipped over a lot of the stuff that would be, I think, the point. So there is this debate about indicator representation. So these are things that just indicate the presence of something or not, and whether or not those are analog. So he makes a contribution to that debate. But I think the main thing is that there's, and this I sort of skipped over because I didn't find it too controversial, but the main thing is, hey, people who are doing these structural representation things in neuroscience, some of these insights that come from the analog literature are relevant to the things that you're working on.
And what are the insights?
And so one of the big ones there was the distinction between the representing vehicle and the computations that it enters into.
People fail to distinguish.
If he's right that isn't being done properly in the structural stuff, that's an
and the
issue.
structural stuff's in
neuroscience.
Yeah.
Yeah, so I probably skipped over the bits that Maley would say are the point of the paper, because I wanted to talk about the stuff that I sort of disagreed with. With that, we'll call it a day. Thank you, Liz. Thank you, everyone.
Thank you. Yeah, shizer. Don't go in a hole early on, Liz, because there's mobs everywhere. Is that a problem?
No, what is a problem is that the cat just changed what set of notes was open on my tablet.